All right, and welcome to Perpendicular Bisectors Level 1. Now, whenever you see this marking like you see here, where you have this arc and it's crossing right there, and this arc and this arc and they're crossing right there, this is what we call the construction of a perpendicular bisector. What a perpendicular bisector does is it cuts any line segment in half. So notice this little tick mark right here and this little tick mark right there. They're telling us that this left half, PJ, is congruent to the right half, JQ. Why? Because when you cut something in half, imagine like $100 bill. If you cut $100 in half, well, half would be 50 and the other half would be 50. And they are, of course, equal, but in, of course, geometry, we say congruent. Now this says line segment PJ is equal to 3x plus 6 inches, and line segment JQ, let's use a different color, is equal to 5x minus 2. And what did we say? PJ must be congruent to JQ because the line was cut in half. Well, since that's true, we can write 3x plus 6 is equal to what we have on the right, that 5x minus 2. Now, we started solving problems like this in our last class. And so the question I would ask for you is, what should we move first? Our variables or our constants? What do you think? And of course, we should always move our variable, and specifically, we want to move the smaller variable. So let's go ahead and do minus 3x. What we do to the left, of course, we want to do to the right, minus 3x. We circle our zero pair. And now we have 6 is equal to 5x minus 2. And so what would you do to get x by itself? Would you get rid of the multiplication, or would you get rid of the subtraction first? And hopefully you said we're going to get rid of the subtraction by adding 2. What we do to the right, we have to do to the left. And what is 6 plus 2? Well, of course, that's going to be 8. And 8 is equal to 5x. Okay. Now from here, how do we get x by itself? How do we get rid of the multiplication? And I kind of messed up my color scheme here. But the opposite of multiplying is to divide. And we divide both sides by 5. Okay? And we're going to get this. We're going to get x is equal to 8 divided by 5 should be 1.6. Go ahead and grab my handy calculator here. Double check that. And of course, that is 1.6. Now, from there, that's not actually our answer, because we want to know what is the length of JQ. So y'all notice JQ is this one on the right, and that is 5 times x minus 2. Well, we take our x value, we plug it in, that 1.6, and we really have 5 times 1.6, which is going to be 8 minus 2, which is 6. And so what we would say is that JQ is 6 inches long. By the way, if JQ is 6 inches long, how long is PJ? Well, it would be 6 inches. All right? And the way you would write your answer is you would write JQ is equal to 6 inches. All right, I hope that helps. Pause the video, finish taking notes. Let's move on to our second example. Okay, here we have example 2, and this time we'll move a whole lot faster. It says find the length of AB, the length of AB, that's the whole thing. When first given, AM, the half, is 3x plus 11, and we're given that the other half, MB, right over here, is going to be 6x plus 2. Well, what do we know? We know that when we're given one half, that 3x plus, not the color I want. Okay. That 3x plus 11, that 3x plus 11, we set it equal to the other half. Sorry, y'all, sometimes it just does not want to tap. That's 6x plus 2. Okay, now from here, how in the world do we solve this? Well, what do we move first, our variable or our constant? And we want to get our variables together, and so we move the smallest one by subtracting 3x from both sides. Now, this is going to give us 11 is equal to 6x plus 2. And then from there, we want to say, well, hey, how do I get x by itself? Do I get rid of my multiplication or my addition first? And hopefully you said your addition. The opposite of plus 2 is minus 2, minus 2. We'll subtract that from both sides. And from right here, we'll just go ahead and use one color from this point forward. 11 minus 2 is 9 is equal to 6x. And then how do you get x by itself? Well, you just divide both sides by 6. And x is equal to 1.5. Now, is x the answer? No. We want to find the length of line segment AB. So the problem here is that we're given the half AM and we're given the other half MB, but we're never given AB directly. So what we have to do is we have to take this 6x plus 2, and we want to take this x equals 1.5, and we want to plug it in, okay? And 6 times 1.5 is going to be 9 plus 2 is equal to 11. So we would say, hey, line segment MB, the half, is equal to 11. Let's go ahead and write that in, 11. And that means the other half, AM, must also equal 11. Well, when you put them together, 11 plus 11 is 22. And so we would say that AB, or line segment AB, is equal to 22. And that's, of course, going to be our answer. All right, I have one more quick example, so please follow me along to example 3. Pause the video if you need to finish taking notes. Okay, in example 3, this one should be pretty quick and easy. It says, which of the following statements is true for the construction below? And let's see, here we have AM. So how do we label these? Let's start with AM. We say, what is AM? Is it a half or a whole? Here we see AM as a half. Anytime we see the congruent symbol, we're just going to put equals. And MB is the other two letters, and that's another half. So I want to ask y'all, is it true to say that half of something, man, if I could write, half is equal to half? And hopefully you would say, yes, that is true. And so A winds up being our answer. Now let's look at something that was clearly wrong. If you look at AB, AB is the whole thing, so let's write whole is equal to MB is the half. And y'all, is that true? Is it true to say that the whole of something is equal to its half? Let's go back to that example of $100. Is $100 equal to 50? No. And so you could just do that for each of these. All right, y'all, I hope this helps, and I'll catch y'all in our next video.